Thank you everyone for attending. We are very pleased to host you here, and let's start the first day with the first technical talk. So I will be talking about the challenges ahead for mid-size scalers like us. That's at least the idea, and I hope that you will see that. As I was saying, challenges ahead for us mid-size scalers. So what this presentation is about. Basically, we believe that everyone in this room kind of shares the same problems. When I looked at the schedule for the 2 days, and when I see all the topics of the talks, all of them kind of resonated with us at Criteo. Sorry, and we felt that we could have made a talk about each of these topics. So we really believe that we have the same problems. We also believe that these problems are getting more complex. The hardware field tends to, grow in terms of complexity, and we think that for people our size, where the team doesn't grow as fast as the hardware gets complex, it's kind of getting more difficult to handle all of what we have to do. And the idea of PremDay is exactly that. It's the idea that if we, put ourselves all together and we help each other, we will be able to achieve more than if we don't. And I hope that you are all already convinced of that, but the idea of this presentation is really to make that more concrete. But first, let me tell you about Criteo a little bit. So Criteo, who are we? We are an ad tech company. We display ads on the internet. And strangely enough, this is an activity that requires a fair amount of infrastructure. Some numbers, we have roughly 30K servers. In itself, that doesn't tell everything, so it's also more than 1 million core, which is probably more telling now. 10-ish, 11 data centers in the world, which changes every year. A little bit more than 15 megawatts, more than 3,500 employees. 500 gigabytes of traffic. It's probably not a large number, but that's mostly because we handle very little packets. But in terms of queries per second, we are at something like 20 million. It's more than 1 trillion bid requests every year. So if we look a little bit, if we zoom in our infrastructure, how is it made? We are running on air-cooled rack at the moment, 12 kVA. We are mostly handling 2 types of workloads: real-time traffic serving, the web traffic, and we also have a dedicated Hadoop data center, which where we run all our batch processing, where we train our model and so on. And in the last couple of years, we've kind of moved to a new model of deployment for our data center, where we are basically creating what we call a carrier hotel. So it's a really small data center where all the internet traffic gets in. And we put data center around this in a star topology with a room of roughly 1 megawatt. In terms of people, how many are we? Because we are mid-size scaler. So if we take the people that are handling the servers, the data center, and the network, it's roughly 30 people. And if we had all the software people up to, let's say, the Kubernetes orchestration platform, the Hadoop cluster, it's roughly, we double the number, and which is 60 people for the infrastructure group overall. And we have fairly typical problems of mid-size scalers. We have a large number of assets. We are running in co-location, and we are using standard SKUs. We are not doing custom stuff. And we are not that many, and so we have a strong need for automation. And our main goal is to be efficient in our job. So we have a few objectives. That's what Matthew gives us every year. So we have to reduce the infra cost. We have to reduce our environmental footprint, and every year these are getting more and more strict. We also have to anticipate, future impact on our infrastructure of stuff like new regulation in the ad tech market or market trends. I'm specifically talking about the privacy sandbox from Google, which has deep impact for us. And of course, we also have to remain competitive against cloud providers. In front of these objectives, we see a set of challenges coming. Mostly, the first one is we see a large density and TDP increase of CPU and GPU, and we will talk about that. The hardware is getting more diverse. It's getting more difficult to optimize for performance. There is more work to do. Monitoring and repairs are still a problem. It's not necessarily getting much better. Firmware management also. And security. And yes, thank you. If the room thinks that these are the big problem for you also, please raise your green thumb. Very good. So let's start with the first one, density and TDP increase. So what we mean by that? I'm guessing it's no surprise for everyone in the room, but there are technological and commercial reasons behind the fact that SKUs are getting bigger. The biggest GPU and the biggest CPU are now reaching around, let's say for the CPU, 500 watts, and almost a kilowatt, even more than a kilowatt soon for the GPUs. On the CPU side, we are looking at more than 200 cores now, so it's significant when we look back 10 years ago. And the vendor in the rooms, they all tell us that air cooling is on its last legs for this. Why is that? I would say that we have to talk about the hyperscalers here because they are accounting now for more than half of the server market, so they tend to have an influence in relation of that, and they tend to influence the roadmap of CPU makers, GPU makers towards these kind of very large SKUs. And so the question for us is, where do we need to go? So we do our homework. I don't know what you think about that, but we think that large SKUs tend to be more effective in practice, but simply economies of scale. And it's the right direction to go. So we want to go in this direction. But if we go in this direction, we also have to accept that we will need to go with very dense, liquid-cooled servers. There is kind of no other ways around that. And the question really is, are we ready for it? So what we do about that at Criteo? So we have the problem. We want to test a DLC rack to see if we are ready for it. We see a lot of challenge around that. Basically, the main one is we think that liquid cooling is kind of mainstream for HPC clusters. It's not so mainstream for CSP workload in colocation. What we see is that colocations are kind of only starting to build real DLC room. Do you agree in the room? Do you think that? Yeah, it's okay. So we will talk about that later. Most of the people agrees, but some disagrees. And of course, for us, the problem is the DLC solutions are very vendor dependent. There is no standardization, so you kind of you have to do the homework several times. And everyone is a bit defensive. So we are doing a POC, and what we've seen is that the hardware vendors and the collocations, they are all defensive. We have, you need to take into account that you will talk about legal stuff, SLAs, and you will need to align that between all the people, and it will take time. So, as I said, what we do, we are doing a POC at Criteo. Around that, we are testing one rack of 40 servers, very dense servers, more than it's a dual core, 160 core each, so more than 300 cores in each server, for a total of 12K core in a single rack. Again, if you look 10 years back, the density has quite increased. And the idea is really to gain confidence that we can run that at scale. The first conclusion, so it's not something that we have finished, but the first conclusion for us is that we are kind of convinced already that we win on pretty much every metric. Just the density is interesting, and the fact that we will use liquid cooling, we will be able to reduce the PV of our data center. It's not totally there yet because we are not in rooms that have, that are first-class DLC rooms. But once we get there, we'll see the increase. And I will mention that the BNP will be giving a more detailed talk about that later today. So of course, if we go with this very dense machine, we need to see if we can handle this densification. And that's a problem in itself for us. Basically, for us, Criteo, we are doing a 5-fold increase in terms of density of our rack, moving from servers that have 64 cores to servers that have more than 300. And it raises a few challenges. What happens if we lose a rack like that? The blast radius is really in question. And all these issues that already exist are only going to get worse. Noisy neighboring, new bottlenecks in the kernel, and so on. Is it something that you also see as a challenge in the room for this? Yeah, okay, so everyone is convinced that, again, that's really the idea about PremDay. Share this and see that we are all on the same track. So what we are doing about that, in our POC, we are going back to double attached server and dual TOR in our racks. Our data center team is looking for DLC ready, the data center where DLC is a first-class citizen. And we are working with the people that are handling the software stack to ensure that we are improving on isolation of workloads, being able to slice a large machine into several mini machines. And that will be also, I think, something that will be touched upon by Booking during their talk. And the last one, important one, we are discussing with our end users to redefine the SLAs in the context of these racks. And really the conclusion is you need to anticipate this density increase, and you need to work with your end user because it's taking a lot of time. The hardware is getting more diverse. That's another challenge. A few years ago, you basically had to choose the CPU and that was it. Now, today, buzzword, but AI, we see at Criteo that we are spending more and more time looking at GPUs and selecting GPUs. So, is it something in the room also that you are spending more time on? Yeah, so your team has probably not grown in size, but it has more work to do, so problem. We also see new architecture emerging. ARM, and we are testing it. And probably for geopolitical reason, but I would not discount RISC-V. I'm personally guessing that RISC-V will be something in the next 5 years. And there are also new objects. I don't know if in the room you are testing those objects, but CXL, memory expansion, stuff like that. So yeah, again, the size of the team hasn't grown, but you have more work to do. And you need to understand more stuff. So really the operational load is increasing, and we think that PremDay is a good venue to share, some of the burden, share presentation regarding the technical information on new stuff that you've tested, and so on. What we are doing at Criteo, we are testing ARM. Of course, the problem is that it's not drop-in compatible with what we are doing. So the idea is that we want to be in a position to switch. We haven't decided to switch yet, but we are doing the work to be able to switch if we think there is value in that. The challenge, I would say the main challenge, is that this work is not limited to, the infrastructure group. There is a lot of work regarding the software stack, and it involves a lot of people that are not necessarily in the decision loop to move to ARM. So you have to convince them and you have to work with them. Hopefully, and that's what we've seen during our testing, but the Linux distro have done most of the heavy lifting. It's in fact very easy now to install a Linux that works on ARM, to install Cube and so on. So really, it kind of works out of the box. A bit of work, but that. And so we can iterate slowly and start to move our applications to ARM, and that's what we are doing. And it's a lot of work, but I would tend to say that it's probably easier than we expected. I don't know if in this room you've started to test ARM. If you do, yeah. So some of you have tested ARM, and I don't know if you share this observation that it's in fact kind of easy. It's a bit of work, but it's kind of easy. Yeah, I see some green thumbs. So the next one, performance optimization. This one is hard because Moore's law is slowing, but it's not dead. And we get two things from that. We get more and more cores in the CPU or GPU, but we also get more features, and that's the important one. The GPU, CPU, and NICs, they are all getting more complex, and so a little bit harder to use. Or rather, they are, they have more and more stuff that you can tweak. These, tunable knobs. Hardware, hardware power management, hardware security, hardware quality of service, and so on. So all this stuff, they are important to use if you want to make the best of your servers. But again, the size of the team is not growing, so it's getting challenging to be able to do all of that. Is it something that you are looking at, using all these new features in the CPU? Yeah. So, and same way, do you share the observation that it's getting more complex? Yeah, I guess so. So what we see is that often these features, they have very poor documentation. They're not really documented. Yeah, and the upstream support is kind of lagging. I will not tell names, but we have example of stuff where it's between the release of the CPU and the support in the kernel for a feature, there are several years, and so it's a bit painful. And the conclusion for us is that we need to work more and more to be able to get the best of our hardware, and that's not a good situation. I've been told that Cloudflare has exactly the same phrase, the last one in their talk. So I guess that there we'll talk a little bit about that too. An example: non-uniformity. No surprise for everyone in the room, but modern hardware is highly non-uniform. It's because of the physical layout. It takes time to go from point A to point B. So if you have 2 points, one closer to point C, it's going to be easier to go to point C from that point. And so cores have varying affinities to varying subsystems in a CPU. And it's not just memory. I guess that the idea is that one NUMA domain is one package. That's an old idea. That's completely no longer the case. It's much more complex and much more subtle than that. Really, it's, you have tons of little stuff that, depends on the physical layout of your computers. And so in the default configuration, we see a lot of jitter, and it's something that is painful for the end users. The end users, they do like deterministic performance. It helps a lot of stuff. For example, outlier detection. If your stuff are varying a lot, it's much more difficult to see that there are outliers. And so they are asking for that. And so what we do about this, like probably everyone in the room, and raise your gun time if you do that, but we are pinning jobs to a set of cores to ensure that stuff are, little bundle that works well. And we see large performance gains from that. For main applications that are, that represent a large volume of our cluster, we see performance gains of up to 20%. And the conclusion is that there is a need for people like us at our scales to deeply understand the hardware architecture to really get the best of it. Another example, still a little bit the same, but network IRQ dispatch. The problem is we want to tie IRQs that are handling the networks for a given applications to the cores that are, handling these applications. If we don't do that, we're going to steal some compute from another application. And it won't go in the sense that we will have deterministic performance on the other application. So we want that, and we also want each core to have a dedicated hardware network queue. Modern NICs have, hundreds of network queue, and so let's use them. The challenge is, and we see that with our very dense machines, with our DLC POC, modern NIC do not expose all their hardware queues. There are kind of artificial limits that you can work around with, configuration, but it's configuration that are under, it's poorly documented, so you have to go look at stuff somewhere on the internet, ask your hardware vendor. It's a little bit difficult, but in the end, you are getting the information. Also, we see that the default heuristic, they are not really designed with, they are still designed with this idea that one NUMA domain is one package, and it's more complex than that. And so we are getting in situations where it's the default placement is inaccurate and generates a lot of jitter. So still this idea. So what we are doing, we're saying we are forcing the NIC to expose all its hardware queue, and we are using this modern feature in NIC that, receive flow steering, or the accelerated versions, where we are asking the NIC to send the network traffic for a queue to a specific core and the reverse to ensure that each, application is really its own, has its own core, and the cores are with the NIC a mini machine that is isolated from the rest. And the result that we've seen is really a flattening of tail latencies. We had tail latencies that went from, around the milliseconds that were unnoticeable in the tens or low hundred microseconds after that. So really a deep effect. Is it something that you are also doing in the room? Some of you are doing that. No, okay. Again, the conclusion is the same. You need to deeply understand the hardware, and there are more and more stuff like that, so it's getting more complex. Monitoring and repairs. They are still a little bit painful for us all. Green thumbs are already raised. I guess that there is a, let's say, a 95% rule, so it's kind of easy to automate 95% of all the monitoring, the hardware problem detection, but the last 5% are difficult. And they often require a manual diagnostic, take times, we need to aggregate data source, really see what's going on. Painful. This is exacerbated by the fact that we are also moving to longer lifetime for hardware. So at the end of their life, they tend to fail a little bit more often, creating more problem. As I was saying, the devices are getting more complex, and so we are getting more complex failure modes than before. Densification will probably have an impact in the fact that we will have less devices because they are denser, and they are going to become a little bit more precious, and there will be that will put more pressure on that, and the false negative, false negative or false positive, if we take a bad decision, that will have more impact. There are also no real standard solution for monitoring, and I guess this is a topic for PremDay, the fact that I'm pretty sure that we are all kind of reinventing the same wheel doing our little stuff, and it would be nice. And raise your green thumb if you think that it would be nice if we all work together on having something that is more standard. Let's say a real open source hardware monitoring tool. That would be nice. Upside in terms of trends is the new hardware have interesting capabilities, self-healing capabilities, in-field scanning, problem detection. Maybe open firmware will be a reality and will help us, understand better, see stuff better. I guess Scaleway will talk a little bit about that in their talk. So really, a lot of stuff. Let's have an example, quick. Reporting problem to our dear hardware vendors. So reporting an issue is hard, and getting it fixed is harder, even. I would say the main issue for us is that it's hard to get access to real engineering in our hardware vendor. It's difficult. There's also the fact that for most of the issues, tooling is not necessarily looking at the right things. When we have complex problem, we often need to, dump some debug registers in devices, stuff like that, and there is no standard tool. Again, there is no. It's really something where you have to talk to the hardware vendor first, so not easy. You don't understand the hardware because the documentation for it is under NDA. You don't have necessarily the whole NDA for that. And sometimes the bug is already fixed by a firmware that was not disclosed, that was not pushed to us. And I see green thumbs. So what we do at Criteo to try to fight a little bit against that, or what we see as working, written report works well. It can be a little bit painful to do that because it takes time, but it's an effective way. It works better when you do a real, your own work, you write a well-written report. We also ask vendor to contribute to open source tools in order to, help us have better visibility. And PremDay is probably part of the answer. So, yeah, the conclusion is, please, vendors, do something about that. It's, one of our most painful stuff in our daily life. And you see all the green terms. Yeah, self-healing diagnostic. We'll go fast over this one, but it's new. We would like to use it. It seems very interesting, but it's not always exposed. And one example for us was post-package repair on modern DIMMs. We had servers from one vendor where the stuff was explicitly hidden and we couldn't use it. That's a bit stupid because no RMA is better than RMA. So do not hide this feature, please. So that's what we are trying to push the vendor for, and also what we are trying to do is automate their use. It's not always easy because lack of documentation, lack of tooling, etc. But yeah, we are trying to do that. Minding a little bit the time, so going to be going a bit faster. RMA is a little bit of a problem for us still. So broken hardware, it costs money. But sending people in data center to repair hardware also costs money. So you have to arbitrate the two, find the right balance. It's supply chain optimization problem. In this supply chain optimization problem, we are paying people to, go in GUI to ask for parts because most of the hardware vendors do not have an API mindset. That's something that is a little bit too bad. We really think, and raise your green thumb if you think that it would be useful for them to have a, kind of an API to ask for parts. So, again, sorry, mining a little bit the time, but we think that in PremDay it would be interesting to discuss with the hardware vendor on that, kind of an open RMA protocol, something where we could discuss and really streamline this problem for everyone. And it will be part of a lightning talk that Arno will be given later today. No pressure. Firmware management. Firmware management, a topic in itself, still painful for everyone. Really, software update, I'm not going to say that it has been solved, but software update, Linux packages, Linux kernel, stuff like that, it's kind of getting to a point where it works, and it works automatically. It's not the case for firmware, and firmware is software, basically. So it's really lagging behind on modern development practices. I don't know if many other vendors are using CI/CD, but I don't think that's the case. There's an automated distribution pipeline, and that will be a talk later today, so please hear it, it's important. Often we don't really know what we need to update, when we are on a server, but do I need to update which component, what is the latest version, and so on. There's no way to get all of that automatically, and it's painful. It's especially painful because there are better open source tools that do that. And we see that working on laptops now. Laptops are, he's in the room, the guy that writes these open source tools. So he will give a talk, and hear him, please, because it's really, why not use something that works, basically. If you agree with that, please raise your green thumb, but what we want is an end-to-end distribution pipeline that is following, that is automated and that follows kind of SREs practices. We want something where someone fixes a bug on the firmware, publish a commit on that, it goes through a CI/CD on the hardware vendor side, you decide to release that, it goes automatically to a distribution place somewhere, and on our side, tools are getting this update automatically and are running it through our CI/CD pipeline also, and progressive rollout and stuff like that. So that's really what we want, and please make it happen. Last one, security. Security is important. We are all handling probably precious data, or at least data of interest for some. And I would say that just the fact that we have a large infrastructure makes us a target in itself. And you're not going to raise your green thumb, but I'm pretty sure that everyone in the room has been, a target of an attack at some point. It's probably a bit specific to the attack market, but probably not that much if you really look. But the regulation regarding handling of private data is evolving, and is evolving in a direction where it is getting stricter. For us, specifically in the attack market, we have the Privacy Sandbox, an initiative from Google, which is pushing for using trusted environment execution engines for handling private data. So, big move. And really the challenges are security is hard, and it's a continuous investment that you need to make. It's not something where you do it once and it's solved. And it's often the third wheel of all investment plans. So we need to collectively step up. One way we could step up as a collective is open firmware. Really on our side, the problem that we have is that we want to be in control of the main firmware on our machines, and we want to be able to audit what's going on. And it's specifically true for all the network devices attached. I'm looking at you, the PMC. And hardware vendors are a bit slow to embrace this subject. There are initiatives, but let's be honest, there is no real off-the-shelf offering, for example, for OpenBMC. I know that some will tell you that there is. It's not completely there yet, especially because we want to be in control. We want the transfer of ownership. We don't want an OpenBMC where a vendor, do it, sign it, and you can't rebuild it. You can, customize it for yourself. So that's really what we want. What we do regarding open firmware at Criteo, we are running Sonic on all our switches. It will be the subject of a talk later today. We are testing OpenBMC also, and we are engaging with vendors on the subject. So really, please, all the room, the clients, if you want that, raise your green thumb so that all the hardware vendors in the room can understand that we want that. It's really important for us, please. And lastly, we have a manifesto at Criteo. You can find it on the internet. It's a summary of our operating principle, and it's a kind of, a summary of what PremDay is about. The idea that we want, an open community with a lot of expertise that is geared toward being more efficient for mid-size scalers. And that's it. Thank you, everyone. We have 5 minutes for questions, so if you have any questions, raise your hand, raise your green thumb. Ooh, big throw. Nice catch.
Hi, everyone. I just wanted to, I have many things to say about your talk. One is about the density. 15 years ago, I was working with another hardware vendor. We made tour on data center claiming that in 2020, you will have 300 watts CPU, and we were blamed and flamed by the data center specialist, okay? So now you have 500 watts. In 2 years, Vera Rubin will be roughly CPU at 1.4 kilowatt, and GPU will be at 5 kilowatt on a socket. And this is just not disclosing things, okay? This was announced last week in GTC. So now listen to us and go DLC. And when we say go DLC, you don't need a pipe. Don't install any CDUs, don't install anything, because there will be no harmonization between vendors, because everybody has a given leaking strategy. Everybody has his own CDU, his own core plates. Do not install CDUs, just bring pipes. And your data center is ready when you have 2 pipes. Mm-hmm. The other thing I wanted to say about the BMC, I have a story about OpenBMC. When NVIDIA bought us the Grace CPU, they said, you will install that with OpenBMC. We said, great, we will do that. Then we went back to NVIDIA stating that if you want to use OpenBMC, we have to patch it, because you are doing things with your CPU that is not done by the other vendors. We have to issue a patch to OpenBMC. And then NVIDIA said, you can't disclose that patch because that will give too much information on our new CPU. So we issued the Grace CPU with our closed source BMC due to hardware vendor, or in this case, NVIDIA locking. That's the challenges we are facing today.
Yeah, I guess we agree on that. We are trying to push the vendors in directions where do not be afraid to open source stuff. That's often not where there is that much value, or the added value of your product. And so please don't be afraid to open source. And it often helps us to, make the product better, because we are the ones that run the product, and if we don't really understand it, it's harder to make it better. Yeah. Go.
Just a quick answer on that. Don't be afraid to open source. Us as vendors, as SoC vendors, often have difficulties where we have to enclose closed source material in our own firmware. So we also want that openness. We also want to free the ecosystem. But in small circumstances, we often have challenges ourselves.
Yeah, but I guess this is a problem for the community. And this is, if we put all ourselves together, we start to have some weight. So I think that's the idea behind PremDay, be able to bend together and try to change stuff. So I think that's it for the time. So thank you very much.